So the question now becomes, what if we have a circuit that is in neither series nor parallel? Instead, we have a combination of the two. So here's a circuit where we have 4 resistors, and it's not all in series nor are they all in parallel. And so how do we actually solve for the resistance, the current, and the voltage at each section of the circuit? So the steps that we're going to go through is the first step, we are going to first find the equivalent resistance. Same as we had done before. Second step, we solve for the current at the battery, using Ohm's law then. Same as we had done before. Then we're going to work backwards, and we're going to ask ourselves the question, are the currents or voltages the same? And then whatever's not the same, we'll solve for using Ohm's law. This will make a bit more sense as we work through the problem together. So first thing is, we're going to combine any circuits that are in series or parallel. So if 2 resistors are in series, you can draw a straight line through them without there being any junction in between. So let's look to see if any of these resistors are in series. So resistor 1 and 2 are not in series because there is a junction in between them. So you cannot have a junction in between them if they're in series. And so for the same argument, resistors 1 and 3 are not in series because there is a junction in between them. And so we see that none of these resistors are in series. Resistor 1 and 4 are not in series because there is a battery in between them. So there cannot be a junction, nor can there be a battery in between them in order for them to be in series. So next we see if any of them are in parallel. To be in parallel means that the top and bottom, or the 2 sides of the resistors, touch each other. And so we see that resistors 2 and 3 are in parallel because the tops and the bottoms touch. So we are going to combine resistors 2 and 3, and so we need the total resistance of 2 and 3. So 1 over the resistance of 2 and 3 together is 1/6 plus 1/6, which is 2/6. But then we have to flip this to make it 6 over 2, which is 3 ohms. Now a shortcut is this. Whenever you have 2 resistors that are the exact same in parallel, the equivalent resistance will always be half the resistance, because we're just saying 1/6 plus 1/6. If it's 1 over x plus 1 over x, is 2 over x. Then when you flip it, it's x over 2. So no matter what the resistance is, if they are the same amount in parallel, the equivalent is half as much. If there's 3 of them in parallel, the equivalent is 1/3 as much. If we have 4 of them in parallel, the equivalent is 1/4 as much, and so on and so forth. So we're going to now combine those 2 resistors, and the equivalent is 3 ohms. So we want to redraw the circuit. We have our 12-volt battery. And this resistor here is still our 2 ohm resistor. And then we have our combined resistors, 6 and 6, which makes a 3 ohm resistor. And this resistor down here is still 7 ohms. That has not changed. Now this resistor here should be familiar. We've already solved for series circuits before, so we're going to solve for everything in this series circuit. So first we solve for the equivalent resistance, and since they're in series, we simply add the resistances. 2 plus 3 plus 7 gives us 12 ohms. Then we solve for the current supplied by the battery using Ohm's law. V equals I times R. So at the battery, our voltage is 12 volts. Our resistance is 12 ohms. And so we get the current to be 1 ampere. In a series circuit, all the currents are the same. So if the current of the battery is 1 ampere, this current is also 1 ampere, this is 1 ampere, and this is 1 ampere. Once you know 2 out of the 3, you solve for the third using Ohm's law. So let's solve for this 2 ohm resistor, the voltage. Again, voltage is current 1 ampere, times resistance, 2 ohms. So the voltage is 2 volts. Solving for the next resistor, we have the voltage is current, which is 1 ampere, times the resistance, which is 3 ohms. So the voltage is 3 volts. And then we solve for the voltage of the 7 ohm resistor. Voltage is current times resistance. Current is 1 ampere, and resistance is 7 ohms. And so the voltage is 7 volts. Good way to check your work. Add up all of the voltages in a series circuit. 2 plus 3 plus 7 gives us 12 volts, the same as the voltage of the battery. Now what we're going to do is work backwards, and as we work backwards, we see that the battery, the 2 ohm resistor, and the 7 ohm resistor have not changed. So at the battery, the equivalent resistance is still 12 ohms, same as we calculated. The current is still 1 ampere. At the 1 ohm resistor, the 2 ohm resistor, the first resistor, we see that that has not changed, so the current is still 1 ampere, and the voltage is still 2 volts. Resistor 4 is not changed either, so the current is still 1 ampere, and the voltage is still 7 volts. However, this resistor here, when we go backwards, has split into 2 in parallel. So we ask ourselves, when they're in parallel, are the currents or voltages the same? And it's the voltages. So this voltage was 3 volts. And so when we work backwards, both of these are also 3 volts. Now once you know 2 out of the 3, you solve for the third using Ohm's law. So Ohm's law says V equals I times R. So 3 volts is equal to I times 6 ohms. And so we get current number 2 to be half an ampere. Likewise for resistor 3, our voltage is 3 volts. We're solving for current. Resistance is 6 ohms. And so our current is half an ampere. Which makes sense. Same voltage, same resistance. We should get the same current. Now a good way to check your work is add whichever value you calculated. 1/2 ampere plus 1/2 ampere. It should add up to be whatever it was when they were combined. 1 ampere. So again, half plus 1/2 is equal to the 1, which is the value when they are combined.